All right, so we're back and we're ready to go. So we just did the complete hypothesis test for Harlow's monkey study. Question was asked, how do we get that 1.96? How do you find out your lines in the sand? So your lines in the sand, the cutoff scores that you're going to use, the areas that you're going to see if your sample mean gets into those or not, those all start with your alpha level. So the first thing you need to do to find your cutoff scores is you need to find your alpha level. So for our question, our alpha level was given to us, it was 0.05. So that will be given to you in the question. It will literally say, use an alpha level of 0.05, use an alpha level of 0.01, and then the last one is use an alpha level of 0.001. Those are the three most common ones in psychology. So whatever alpha level you get, that's where your lines in the sand start. First step you want to do is convert that percentage convert the decimal into a percentage. Percentages are what your table has. All right, so notice here, percent in the tail, right? Not decimal percentage in the tail, but like actual percent in the tail. So take that decimal, change it to a percent. 0.05, that's 5%. Then what you want to do is you want to see, is it a one-tailed test or is it a two-tailed test? In our case, it was a two-tailed test. That means that this 5% goes into, this 5% is how much area is in all your tails combined. So all of the tail regions of your comparison distribution has to make up alpha. So for a one-tailed test, you would put it all into one side. For a two-tailed test, you have to split your alpha in two. So we take this 5% and we put 2.5% in the upper tail of our comparison distribution, and we take the remaining 2.5%, we put it in the bottom tail of our comparison distribution. So now we got 2.5% in the bottom tail, 2.5% in the upper tail, and now finally we're ready to consult the normal table. So we go to the normal table here, table A1 in your textbook, and you will need it for the exam. You cannot do this exam without the table. And then what we do is we look for percentage in the tail. This is the column we want. We want percentage in the tail. And we scan down until we find the percentage we're looking for, until we find that 2.5%. Oops, did I not have that one animated? Until we find, no, not 5%. Until we find, almost there, 2.5%. All right, so we go to the percentage in the tail until we find 2.5%. Then what we do is we look up the z-score. So on this, make sure that you know which column you're looking at. You look up your percentage, then you go to your z-score. All right, don't fall for another column. So we go to our z-score associated with 2.5% in the tail, and that's 1.96, and that's where your line in the sand comes from. That's where that 1.96 comes from. Now, if we had the opposite kind of test, if we were doing a one-tailed test, which is what I had here, then what we need to do is we don't have one of the tails, right? So if all we were trying to predict, or all we were trying to test, is there a preference for the terry cloth mother? If that was our question, a directional question, do they prefer the terry cloth mother? Do they spend more time with the terry cloth mother? If we were only looking in one direction, then what we do is we take our alpha and we put the whole thing into the direction that we're looking for. So if we were looking for, do they spend more time with the terry cloth mother, we put it in the positive, more time part of the curve. If we were asking, do they spend less time with the terry cloth mother, we would put it in the negative side of the curve, right? The minus side, the smaller side. So in this case, let's say that we were asking, do they spend more time with the terry cloth mother? Then we put all 5% into the tail. We go to our unit normal table, we want 5% in the tail. That's as close as we can get. It's 5.05, the other one is 4.95, both equally close, both good enough for the exam. You can use either one. We're gonna go with 5.05 for this example. We scroll across, 1.64 is our cutoff score. So if we were doing a one-tailed test, not 1.96, we're gonna put 1.64 instead. And if we were doing a decreases test where we had our tail on this side, we would put minus 1.64 to indicate that we're looking for a decrease. And that is how you do step 3, where you find your lines in the sand. For the exam, when you do your hypothesis testing in the exam, let me bring that up real quick. All right, so for the exam, for your lines in the sand, for step 3, your Z critical, if it is a two-tailed test, I'm going to assume you mean plus and minus. All right, so if it's a two-tailed test, I'm going to assume you mean plus or minus. So you don't have to worry about putting plus or minus in there. Just put the answer, just put your lines in the sand, the numerical value. So if it's 1.96, just put in 1.96. And for a two-tailed test, I'm going to assume you mean minus 1.96 and positive 1.96. So it's not like your homework where you have to put in both and you put the comma between. Don't worry about that. You can just put in 1.96 for the two-tailed test. I'm going to assume you mean both sides. For the one-tailed test, though, you need to specify the sign. So if I'm asking you, was there a significant increase, then your cutoff score has to be positive, right? Because a positive cutoff score is looking for an increase. Did the values go up? Was there improvement? The language will be very clear as to what direction we're looking for. So pay attention to the language. Did scores go up? Was there improvement? Did scores increase? Did subjects get better? Those are all indicators of looking for increase. So that would mean a cutoff score with a positive value. So make sure that you have a positive value. You don't have to put plus, just put in the actual value. If it's a minus, if we're looking for decrease, like did depression decrease? Did alcoholic symptoms decrease? Did self-esteem decrease? Did scores go down? Was there loss? Was there less of? Was there a diminishing of? Was there impairment after the treatment? The language, again, will be very clear that we're looking for less of. If that's the case, then you need to indicate your cutoff score, and it needs to be negative, indicating that we're looking for the minus side of things. So let the question decide which way you're going with your cutoff scores. Do not let your sample mean decide which way you're going. So it is not allowed, and we haven't even talked about it because it's not allowed, but you can't say, well, my sample seems bigger, so let me test if there's an increase. Or, oh, my sample seems smaller than the general population, lower mean than the general population, let me test for a decrease. You're not allowed to do that. That is bad statistics. So the question will say, we're looking for an increase. If we're looking for an increase, positive cutoff score. The question will say, we're looking for a decrease. If we're looking for a decrease, one-tailed, negative cutoff score. And then the other option is, the question will say, is there a change? Was there an effect? Did the treatment make a difference? Did the treatment do anything? That is just looking for change. That is just looking for an effect. Then they'll say, do a two-tailed test. That's where you have both tails, and I will assume that you mean we're looking at both, you mean positive and negative. So you don't have to put it in for that. I'm going to assume you mean positive and negative. All right, so that was that particular question wrapped up. So what we're going to do right now is just real quick, well, not real quick, we got time, but I want to go over next this question here. Specifically, I'm going to go over question, let's do 5. I think we already did question 4 a couple of times with other individuals. So we'll do 5 over here, question number 5. So you will see questions that are exactly like this on the exam, where I will give you a distribution, I will give you a population distribution, I will give you a score and ask you for a percent, and I will give you a percent and ask you for a score. So this is stuff that you will see. Now, one thing to keep in mind, these have steps to them, just like hypothesis testing does. There are steps to do this, so you might want, it might be a good idea, and let me see if I chose the right slides here. you might want to have the slides ready to go so that you're not doing what I'm doing right now. You're going to want to have the slides ready to go that have the steps for these particular questions. So those slides are in, I believe, all right, there we go. Those slides are in week 6, class 1. Make sure that you have those and that they are ready to go if you don't have this down pat. And even if you do, make a note of it where they are. Again, you'll have access to Canvas. There's no issue there. So there are steps when you start with a raw score and you're going to get a percentage. And then there are a separate set of steps when you're starting with a percentage and you need to get a raw score. So follow that. The only thing that I'm not going to do here is that make a rough estimate, because that is just a double check. That's not required. And I just want to make sure that we do have a good understanding of how to do the rest of this. So let me bring up this question. There it is. And let's give this a shot. So IQ scores are normally distributed with a mean of 100 and a standard deviation of 15. So that is the standardized scores for a normal, for an IQ test in the United States. So people with an IQ greater than 140 are considered to be geniuses. What is the percentage of geniuses in the population? So if people with an IQ of 140 or greater are what we call geniuses, what percentage of our population is walking around with that genius level IQ? So this is the population distribution. It's a horrible drawing, but it's going to serve our purposes. So you want to draw that out. It has a mean of 100. It's got a standard deviation of 15, all right? And what we want to know is people with IQs that are 140 are considered geniuses. What is the percentage of geniuses? So there's 100. Let's just say that this line right here is where 140 is. All right? You don't got to be exact about this. You just need the visual. So is that actually 140? Probably not. You know, but all we need is the fact that we have the right type of a curve. Next thing you want to do is ask yourself which part of this needs to be shaded. So it goes, people with IQ greater than 140 are considered geniuses. So what is the percentage of geniuses? Well, here's 140 right here. If you're less than 140, you're not geniuses, right? These people here, they don't classify, they don't meet the criteria. You have to be more than 140. So the geniuses are all these people here. So this is the percentage we want. We want to find out what percentage is this of the entire curve. So now we have that, we're ready to go. We need to figure out what is that percentage. So what we need to realize, and this is a common theme, is that this normal curve is nowhere in your textbook, right? We don't have the numbers for this normal curve in an appendix in your textbook. So what we need to do is we need to take this curve and we need to transform it into a normal curve of z-scores. Z-scores that have a mean of 0 and a standard deviation equal to 1. All right, so we need to transform this into our z-scores, and then we need to figure out what is that percentage. So we know that when we transform the mean and the standard deviation into z-scores, it's going to be a mean of 0 and a standard deviation of 1. That's what a z-score is. So we don't got to do any math on that. What we don't know is what is that 140 going to change into. So we need to do that calculation. What is that 140 going to change into? And this is where we use our formula that a z-score equals, in this case, your raw score minus your mean, all divided by your standard deviation. So we plug in our z-score, our raw score is 140, right? That's the IQ. Minus the mean, which is 100, all of that divided by the standard deviation, which is 15, So we got 40 divided by 15, and I think that's what, 2.3, 2.666666. All right, I think that's the right number. You can double check on your phones, that'd be great. But anyways, I think that's the correct z-score. Anybody back me up on this? Yeah, cool. All right. So we got that z-score 2.67. So we converted 140 into 2.67. Now we're ready to go to the unit normal distribution table. Now we're ready to go and find out where is that 2.67. So once again, when you get to class on Tuesday, make sure that you are signed in to Canvas. Make sure that you have this all ready to go, so you're not doing what I'm doing during exam time. And you will need that unit normal distribution table. You will need that table that I'm going to bring up right now. So one thing to think about, make sure that you have all this open. Make sure that you got your textbook open. This is my first time signing in today, and I just saw the quarantine spring break announcement. It's always a fun thing to pop up. So anyways, I'm just getting into the textbook right now. Just bear with me while I do this. Incidentally, this might be a good time. Nobody scream out the answer. See if you can find the percentage. So we're looking for the percentage that is associated in the tail with a z-score of 2.63. So see if you can get that on your own, and then I will go through it and just kind of corroborate with you what exactly it is. Anyways, just to kind of give you the principle behind it, we know the z-score. We're looking up a percent. So if you're calculating a z-score, you go to the table to look up a percent. If you're starting with percent, you go to the table to look up a z-score. Everything goes through the table. So you're either going to the table to look up a percent, or you're going through the table to look up a z-score. One very common error in this in this type of a question is to look at a percent, is to look at the wrong column. So this 2.67, that's a z-score. Make sure you're looking up 2.67 in the z-score column, because you can find a percent of 2.67, right? You can't find 2.67%. That's not what we want at all. So make sure that you're looking up in the right column. So one more time. Looks like it's all good now. I think it might have been a little quicker to go to the library and actually get the physical copy of this textbook. Oh, trying to flex his processing muscles now that I'm embarrassed. Okay, so we're looking in the z-score here. Where is that z-score of 2.67? So it's not on this page, so we got to go to the next page, and we go to the next page, and we wait for it to load. All right, and it's not going to, it's not going to be on this page either. All right, so once again, in the z-score column, we're looking for 2.67. We found 1.43. Let's go one more. All right, so it's going to be on this one here. So let's see what we got. Okay, so we're looking up 2.67 for our z-score. So we scan. We got our z-score right here, 2.64, 2.65, 2.66, and then finally 2.67. Are you there? Oh my goodness. All right, so you get the idea. I didn't want to give up on this because I wanted to bring it to the end, but who looked up a score of 2.67 on their z-score? Oh, you got one? We have a document camera. All right. I shall not be defeated. Can I borrow that real quick? Thank you. All right, we'll go ancient if we need to, but where is this? And how do we focus? Come on now. Well, this has just been a highly disappointing and educational day. Will it not focus? Oh, wait, here we go. Auto? Yeah? Yes. All right. So, what we do, we look up. Autofocus, thank you. We look up 2.67, there it is. All right, so 2.67 in your z-score. All right, and then, you see there, then we scroll across from 2.67 and we find, no, this way, 0.38, all right? So 2.67 is associated with 0.38. I'm trying to move in 6 dimensions here, but 2.67 is associated with 0.38. So, thank you. So that is our final answer. We got there eventually. So that is our final answer. The percentage in here, and be very careful about that, the percentage is 0.38. So less than 0.5% of people in our population are walking around with genius level IQs. So 0.38%, that is our final answer. 0.38% is how many people are walking around with an IQ of 140 or greater. All right, so that was the very long, start with a raw score and then go to a, get a percentage version of this. The other version is start with a percentage and get yourself a raw score. So those, that number there is associated with genius level IQ. The other question that we have is question B. We're starting with a percentage. People in the top 9.18% of the population are considered to have very superior intelligence. So these are actual demarcations that they can give people. So, oh, you're a genius, you're a very superior intelligence, you're superior intelligence, you're above average. These are all thresholds that they have listed. So what IQ score is required to reach this level? So if you wanted to pop that on your CV, which would be a little weird, but let's say that you wanted to do that, what IQ score do you need? So in this case, we're starting with a percentage. So we know what percentage we want. We want 9.18. And again, we know what we want, which area we want, right? So it's 9.18 in the tail, because you have to be at least that high of an IQ score or higher to have very superior intelligence. So we once again want this tail, but now the question is, what's our raw score? What IQ do we need? So for this one, we don't have to go to the unit normal distribution table to look up the percentage, because we already have the percentage. It's 9.18%. What we need to do is we need to figure out what z-score gives us that 9.18%. So what we do is we go back to that table that showed us so much love so far, and so we go back to this table, and once again, make sure that you are looking in the right column, the correct column. So go to your picture, percent in the tail. We want percent in the tail and start looking for 9.8. So we got 25.78, not there yet. So we go to the next page, and we're looking up percentage in the tail. I don't want to go back to the doc cam, so let's hope it's on this page. Yes, it is. All right. So once again, percentage in the tail. Big part of these questions, make sure you're looking at the right column. So we don't want a z-score. That's what we're looking for. We don't have that number yet. We don't want from the mean to z. That's the wrong area. We want percentage in the tail. So we scroll on down. We're looking for 9.18. There's 9.18% in the tail. We go across. There is the z-score. So you need a z-score of 1.33. That is going to get you into the top 9.18%. So now we know the z-score that we need, and all that's left is for us to figure out what is the raw score? So what actual IQ score do you need? And for that one, we go to the formula that your raw score equals your population mean plus your z-score multiplied by the standard deviation. That's the formula you're looking for to get your raw score. So our population mean is 100. That's the mean IQ scores. And we're using this information because we want to transform our raw score into an IQ score. So we can get our IQ score a mean of 100 plus the 1.33 that we just found out, multiplied by our standard deviation of 15. So that will equal 100 plus 20. So 1.33 times 15 is 20. So we need an IQ of 120 in order to get into that very superior intelligence. So that is finally the answer to those questions. And you will very specifically see questions like this. You will very specifically see questions where it's, here's your population distribution. What score do you need to get into this percentage of the distribution? And then here's a percentage of the distribution. Here's a percentage. What score do you need to get into that percentage of the distribution? Or here's a score. What percentage of the distribution are you in? So it's going to be starting with a score, getting a percentage, starting with a percentage, getting with a score. The slides have those steps that are going to be, that you're going to follow. The only one that you will not need to do is the step where you double check against the estimation. You make that rough estimate. That's just a backup plan. If you're feeling confident, you don't need to do that on the exam. I will not ask you for your estimate. All I will ask you for is what is your raw score, or alternatively, what is your percentage? All right, we got about 5 minutes left. So any final questions about anything, let me know. But we've kind of gone over the majority of what's going to be on the exam. So hopefully everybody's feeling prepared. And just a reminder that if you are doing the MyStatLab study plan, if you are earning those mastery points to supplement your pre-test scores, make sure that you get those completed by midnight before the exam date. That's when the deadline is to earn those percentages on your mastery points. All right, so we got one more? Yep. Okay.